one is or the one is used for the itself, or SCSI controller itself represents a separate physical unit. So the total peripherals connected will be 16. One is the SCSI controller plus 15 other peripherals. So the total they will become the 16 peripherals. Next topic is the addressing of peripherals. In a SCSI interface, peripherals they are addressed using the identification numbers. The first number is the ID, which is a number designating the controller built into each peripheral. The peripheral may have up to 8 logical units. These logical units they are identified by a logical unit number. So to accommodate with a peripheral, the computer must give an address in the following form: card number, ID and LUN. Now what is the card number? A computer may be having more than one SCSI controller or SCSI controllers. Then first one is the number of that card or number of that SCSI controller. Then is the identification number or the ID, and then is the logical unit number, means how many logical units are there in the peripheral. So the complete address will be like this: card number, ID and LUN, or card number, identification number and logical unit number. There are two types of SCSI buses. The first one is the asymmetrical bus and second one is the differential bus. Asymmetrical bus, these are also known as the single ended or SA. It is based on a parallel architecture in which each channel circulates on one wire. The SCSI cables in SC mode have 8 wires for 8-bit transmission, as there is a parallel architecture, 16 wires for a 16-bit cable. So asymmetrical bus is based on a parallel architecture in which each channel circulates on one wire. The differential bus carries signals to a pair of wires. The information is coded by the difference between the two wires in order to offset the electromagnetic disturbances, which allows a considerable cabling distance. Generally speaking, there are two modes in the differential bus. The first one is the low voltage differential. It is based on the 3.3 volt, and second one is the high voltage differential. It is based on a 5 volt signal. So there are the two modes for the differential bus: low voltage differential and the high voltage differential. Now there are the various SCSI standards or SCSI, as pronounced SCSI standards. The SCSI standards define the various electrical parameters of the input-output interfaces. The SCSI 1 standard of 1986 defined the standard commands for controlling the SCSI peripherals on a bus with a frequency of 4.77 MHz with width of 8 bits, meaning that speed of 5 Mbps megabits per second can be achieved. Or we can say that on a SCSI standard, whenever there is a clock speed is of 4.77 MHz and the bus width is 8 bits, then it is called as the SCSI 1 standard or SCSI 1 standard. SCSI 2 SCSI 2 standard, it was adopted in 1994. SCSI 2 standard defines 18 commands known as the Common Command Set, CCS. It is known as the CCS, Common Command Sets. 18 commands are there in the SCSI 2 standard. Various versions of the SCSI 2 standards have been defined: the wide and the fast, wide SCSI 2, fast SCSI 2. The wide SCSI 2 is based on a bus with 16 bits. As in the SCSI 1 there was 8-bit bus, but in the SCSI 2 there is a 16 bits, and it offers the capacity of double to the SCSI 1. There was 5 Mbps, now there is a speed of 10 Mbps per second. And fast SCSI 2 is a rapid synchronous mode, allowing an increase from 10 to 5 to 10 Mbps from the standard SCSI and from 10 to 20 Mbps for the wide SCSI 2. The fast 20 and fast 40 modes respectively double and quadruple these speed. So, what is the difference between the SCSI 2 and fast SCSI 2? It is a rapid synchronous mode, and it allows an increase for SCSI 1 from 5 to 10 Mbps, and from SCSI 2 10 to 20 Mbps, or it doubles the speed as it is used for the standard SCSI. It is doubled from 5 to 10, and if it has been used for the wide SCSI, then it doubles it from 10 to 20 Mbps. Next is the SCSI 3 standard or SCSI 3 standard. The SCSI 3 standard includes new commands and allows chaining of 32 peripherals and a maximum speed of 320 megabits per second in Ultra 320 mode. Or we can say that in SCSI 3 standard we can connect the 32 new peripherals and a maximum speed of 320 in Ultra 320 mode. There are various modes in SCSI 3 standard like Ultra 2 SCSI, it allows 40 MB per second, Ultra 2 wide SCSI, Ultra 160, and last one is the Ultra 320 mode. In Ultra 320 mode, a maximum of 320 megabits per second speed can be achieved in the SCSI 3 standard. Next topic is the ports. Port is a connector into which you can plug cables from external devices, or in some cases in the device themselves. There are two common port types which are serial and parallel ports. What is the difference between the serial and parallel port? First, serial port. In serial port there is a serial transmission of data. As discussed earlier, if we transmit the 8 bits serially, then there is a need of single wire for the serial interface, and these 8 bits they are transmitted one by one. And in the parallel ports, if we are transmitting the data of 8 bits, there is a need of 8 wires, and each wire will be transmitting 1 bit parallelly to the other peripheral. So there are two ports, serial ports and the parallel ports. Serial ports, these are the connectors into which you plug devices that use serial transmission to communicate with your PC. Serial ports mean the communication oriented ports to which the devices are connected, such as modems. These are the serial devices. They are called communication or COM ports. Basically, a personal computer supports 4 communication or COM ports, and these are called COM1, COM2, COM3 and COM4. So a PC can have 4 communication for serial communication ports, and these ports are named as COM1, COM2, COM3 and COM4. Only 2 can be used at a time. So from these 4 communication ports, only 2 can be used at a time. as from the table you can see the various serial port resources. There are the 4 serial port resources: COM1, COM2, COM3 and COM4. COM1 port use the interrupt request resource 4. So the input output address for this COM1 port is 03F8 to 03FF, and this address has input output address has been shown in the hexadecimals. Next is the COM2 port. COM2 ports use the third interrupt request, and for the COM2 port the input output address is 02F8 to 02FF, as this address has been shown in the hexadecimals. Next is the COM3 port. COM3 port, it again uses the IRQ4, and the address is also same as it uses the fourth IRQ 03F8 to 03FF. So COM1 and COM3, they use the same IRQ. And next one is the COM4, communication port 4. It uses the third IRQ, and the input output address is the 02F8 to 02FF. So we can see from the table COM1 and COM3, they are using the same IRQ, that is the fourth IRQ, and their input output address is also the same. And similarly for the COM2 and COM4, or we can say communication port 2 and communication port 4, they use the third IRQ and the same input output address, and that is the 02F8 to 02FFF. So as I have said earlier that we can use the maximum 2 communication ports, or COM1 or COM2, communication port 1 or communication port 2 at a time, or we can use the communication port 3rd or communication port 1, only single from the communication port 1 and 3rd, and another one is the from communication port 2 and the communication port 4. As communication port 1 and communication port 3, they use the same IRQ, and communication port 2 and 4 use the same IRQ, that is the third. So we can use the 2 ports at a time. I have said earlier you COM ports 1 and 3 and COM ports 2 and 4 share the same IRQs. This means that you cannot have COM ports 1 and 3 or 2 and 4 enabled. I have said earlier that you can use the maximum 2 communication ports, that is COM port 1 and 3 or 2 and 4 at the same time, unless you reconfigure one of the ports to use different IRQ. If you reconfigure the ports, these communication ports, then you can use more than 2, but you have to reconfigure these ports to use the different IRQs. Next is the serial port characteristics. First characteristic is the port speed, the rate in bits per second at which data communications proceed over the COM port, that is the port speed. This speed controls how fast your computer interacts with the serial device, not that device communication speed. Next characteristic is the data bits, the number of bits of data sent within a single block. And as the data is sent in the block, so we have to identify the starting and ending of the data. So there are the start and stop bits, the number of bits added before and after the data to designate the beginning and end of the data within a block. Often this value is configured as just the stop bits. Next is the characteristic is the parity. Error checking method used over the COM ports is the parity. The various choices in the parity are: first one is the none, means you have disabled the parity checking. Second one is the even. If the sum of the data bits is even number, the parity bit is 7 to 0. If the sum of the bits is odd, the parity bit is set to 1. We can say that in the overall total, the number of ones, it should be even, or the number of sum of the data bits must be even. Next, odd. If the sum of the data bits is an odd number, the parity bit is set to 0. If the sum is even, the parity is set to 1. This way the sum of the data and parity is always an odd number. Next mark, the parity bit is always set to 1. Next is the space, the parity bit is always set to 0. Next characteristic is the flow control. Flow control is a means by which communication over a serial port can be slowed down or even stopped to permit the devices involved to keep pace with with communication. The various choices in the flow control are none, means we have disabled the flow control. Hardware devices use a separate flow control wire within the serial cable over which handshaking signals are sent. Through these signals, devices can start and stop the communications. And the next setting is the X on and or X off, a software handshake technique in which we transmit an X on and transmit an X on signal are sent over the same data communication lines as we transmit the data. The receiving devices send the X on and X off signal to the sender as an acknowledgement. Next is the parallel ports. On the parallel ports, the data is sent parallelly. As I have said you earlier, say if there is a 8-bit transmission, then there is a need of 8 wires for the parallel ports. And the various parallel ports, they are LPT, line printer ports. And in the LPT ports, the ports are LPT1, LPT2 and the LPT3. We can also add the additional ports through the expansion adapters. And the various addresses for the parallel ports are for LPT1 is 0378 to 037F, and for LPT2 0278 to 027F, and for LPT3 03BC to 03BF. And these addresses they have been shown in the hexadecimal addresses. Next topic is the USB. As the name tells, USB is the universal serial bus. It is a port on computer that allows external devices to be connected simply and easily. It is a protocol for transferring data to and from digital devices. It is known as a plug and play interface between a computer and a low speed peripherals such as a mouse, keyboard, digital camera, printer or scanner. Unlike devices connected via SSI ports, USB devices can be added to and removed from the computer without having to reboot the computer or restarting the computer. It is called hot swapping, and it makes additional peripheral devices so easy. Standardized connections are for the USB, and for USB up to 127 devices can be connected. Legacy serial and parallel devices can be connected with the adapters. In USB there is a serial communication, or we can say, as its name tells, that universal serial bus. For the USB there are 2 ports. These are the USB type A port and USB type B port. Type A ports, they are simple as their shape is rectangular, and they are generally used for low bandwidth intensive devices. Type B ports, they are square in shape and generally used